Recommendation 4, having students see multiple solutions for a particular problem, is a fairly novel idea for American teachers. After all, research has shown that the typical practice usually goes something like this. Teachers go over the answers to problems. Sometimes they stop and focus on a solution to the problem and then, move on to the next one. This is very different from what occurs in other countries throughout the world. For example, in Japan, they spend a lot more time on fewer problems, and the biggest piece is they have students at the end of the problem solving communicate different solutions to those problems. I've been fortunate enough to see this kind of thing happen in action. And I was particularly impressed in one occasion where students were given the problem, add the numbers 1 to 50. And the teacher began by having the students add 1 to 10 and look for patterns. This kind of make a simpler version of the problem was a strategy that prompted kids to think about different solutions to the problem. When the kids were done, they actually showed 4 different strategies for solving this problem. I was really, really impressed. This is the essence of what How-To Step 1 is all about. This idea that through different solutions, kids will be exposed to different strategies and create more flexible thinking as they solve problems. How-To Step 2 is really one of the most intriguing steps to me in the entire problem-solving guide. Rather than having students read a problem, work a problem, find a solution, what teachers do is show students 2 solutions to a problem that's already been worked. So it's the same problem, you have 2 different solutions. Think, for example, of teaching a multi-step algebra problem where there's an equation, and the teacher's goal here is to get kids to see the value of using the distributive property or possibly getting rid of the coefficient in the problem by multiplying each side by the reciprocal. That's the teacher's goal. By comparing 2 different solutions to this problem, students can see greater efficiency in one method over the other. You can also think of cases where in one problem a student would use a visual representation, and in the other problem the student didn't use a visual representation and it perhaps led to an error. These are different ways teachers can use pre-worked problems that lead to the same solution and talk about the different methods that we use to solve the problem. Another way to do business is to simply draw upon what students have already worked and make those kinds of comparisons. So, for example, students may use 2 different kinds of visual representations to solve the same problem. And it's a way of getting out in front of kids the value of different representations for solving problems. How-To Step 3 focuses on students generating different solutions to the same problem, either working individually or more likely in pairs or in small groups. Now there's a delicate issue that goes on inside of this, and that is that teachers need to be artful about the way they debrief different solutions to the problem. One of the last things teachers want to do is communicate in this debriefing that some solutions are much better or superior to other ones and that the other ones are inferior. For those kids who generated the inferior solutions, obviously this is not the greatest effect and it tends to silence them and make them reluctant to participate further. So they have to be very careful about the way they debrief the different solutions to problems. But there's another piece here in How-To Step 3 that I think is very important to underscore. And that is that, as is recommended in Recommendation 5, students are given the opportunity to articulate their thinking. And there are really 2 parts to this. They not only explain in full how they solved a problem, but they may be put in a situation where they actually defend their thinking. These 2 components in articulating your thinking around problem solving, explaining and defending, are very important mathematical practices, and they're really key to math in the world today. There are a couple of roadblocks that we need to think about when we encourage teachers to use multiple solutions in the problem-solving process. The first, which I think is pretty obvious to a lot of teachers, is this is pretty time-consuming. And what that suggests quite simply is you're only working on a couple of problems, not an entire bank of problems. There's a lot more that can be gained by working on fewer problems. And of course, there'll be the need to assist students who struggle to revoice their statements, enabling them to be successful in the way that they talk about their particular solution to the problem. A second and more common roadblock that occurs in this kind of problem solving is one solution, and then the next solution doesn't vary that much in its content. I mean, they're just minor variations on the solutions. And a good way to address this is for teachers to keep a bank of solutions that have occurred in past classes for this particular problem. I can think in particular of teachers saying, oh, hey, here's a way a kid last year solved this problem. Let's take a look at this. And this particular solution is markedly different from the one that may have been just discussed. I think you'll find this practice of multiple solutions to be an incredibly valuable one for your practices in your math classrooms today.